So on number 28, we left off on 30. And actually through 31 through 45, there's like 4 or 5 BC questions that are not even on there anymore. So a lot of these questions, there was a lot of BC stuff on here. I went back and looked, and they don't even teach that on the AV. And if you look at the answer key, they'll say it is now on the BC exam if you look through it. But number 28, we looked at this one yesterday, and I want to look at it one more time, kind of revisit it, because you would have to be able to do this without a calculator. Okay? So here's how you do it. And if you didn't understand this yesterday, think about this. You've got basically the area from 1 to 50, or 1 to 500. And the problem is, those of you who tried to do this on the calculator, and I'm quite confident they would not have this on the calculator part, but because they were allowed to use a scientific calculator on the whole exam, they didn't leave a lot of their answers in log form. So a lot of times they would give you decimal answers. But anyways, from 1 to 500, you have this area. So you have all this area from 1 to 500. And then you have a different area from 2 to 500, but it's so similar. Okay? So it's actually a different, you kind of think it, you look at it right away and you're like, well, they're not even the same graphs. You're not even finding the same area of the curve, but you can make them the same graphs. And this is the part you really need to make sure you understand. This is so closely related. The reason they would give you a problem like this is just to demonstrate whether or not you know how to use a property. Okay? First of all, you're adding two integrals, which we know we're allowed to do. But what would happen if I change this function so that it looks exactly like this? Well, all I have to do is realize that they only differ by a negative. Okay? This function and this function only differ by a negative. So what I would do is I'd factor a negative out of that. Okay? Factor a negative out of it. So I could rewrite this problem so that it's 1 to the 500 of 13 to the x minus 11 to the x dx. And what would happen here if I factor a negative out of this? I would have 2 to the 500, factor a negative out of it, make it minus 11 to the x and plus 13 to the x, which is this. So if you go like this, minus, let's see here. I factor a negative out, we're going to have negative 11 to the x plus 13 to the x. Everybody see that?
Which is the same thing.
Which is the same thing. So now you throw the negative in front of the integral, and they get 13 to the x minus 11 to the x. Now this additive property really makes sense. Because you go, okay, well this is the area, so now we'll say this curve is 13 to the x minus 11 to the x. So you've got the area from 1 to 500, and then you have the area from 2 to 500, which we'll do is this. And if you take the area from 1 to 500 minus the blue area, which is 2 to 500, you're going to be left with the area from what? 1 to 2. Now here's the part that gets interesting. This is the reason I wanted to redo this one. You need to know how to do this by hand. Something like this. They will do, I tried to look and kind of search and look and say, all right, we know we have to be able to do a to the u by hand with a derivative. Like, we can do the derivative of a to the u. Now watch this. This is where it gets interesting. A to the u, what's the derivative of a to the u? Itself times ln a times du dx. Now when you look at this, it's really not as bad as you think. You don't even need u substitution. Like technically you could, I guess, but you don't need it. Because remember what we said when we did integrals of this? Like when we did the integral of e to the u, du, we said if there's something here and we need chain rule, that's what we're going to let u be as the exponent and e to the u. That's what we did on the quiz twice. But the problem is they're just x's here, so it's nothing special. So just think about the derivative of 13 to the x. If I took the derivative of 13 to the x, it'd be itself, watch, let's just do 13 to the x. If you do the derivative of 13 to the x, what would the derivative be? 13 to the x times ln of 13 times 1. So there's nothing special in the exponent. It's just this 13 to the x you're going to get. So, or natural log of 13, sorry. You're going to get the 13 to the x and you're going to get the natural log of 13. Now think about that here. You're going to get the 13 to the x and you should have a natural log of 13, but where'd it go? Where did the natural log of 13 go? The only way it could have canceled is there had to be a what?
E.
Nope.
It's on the bottom.
there had to be a 1 divided by natural log of 13 for it to cancel. Think about it. So the antiderivative of this had to be 13 to the x itself. You know when you multiply by the derivative, you're going to multiply by natural log of 13. Well, the only way that disappeared is there had to have been a natural log of 13 on bottom. Same thing for here. Minus, there had to be 11 to the x, and there had to be a natural log 11 on bottom. And then you evaluate from 1 to 2. Think about it. If you take the derivative of this now, it's still 13 to the x times what? Let's change it now. Let's don't just make it derivative. Let me just write it over here, because otherwise I don't think you'll get it. Remember, you have to see it broken apart. Okay, so I've got 13 to the x divided by natural log of 13. Natural log of 13 is just a constant, right? It's a constant multiple rule. What's the derivative of 13 to the x? 13 to the x times what? Times ln 13. But you already have this ln 13 where? On bottom. What happens to it? Does that make sense now? Okay, it's pretty doable, and I guarantee they're going to try and do something like that. I'm not saying it's going to be this exact problem, and I'm not even going to say it's going to be this hard, but it's the same idea. You've got to be able to do those kind of things in your head. All right, so now you just plug in 2. So what you get is you get FTC now. You get 13 squared divided by ln 13 minus, is that right? Yeah, 11 squared over ln 13 minus ln 11, sorry. And then you get 13 to the first power over ln 13 minus 11 to the first power over ln 11. And you just type it on the calculator to get one of these decimals. They only had a scientific calculator, remember? They didn't have a calculator, they had derivatives of integrals. So I kind of asked myself, I said, okay, this is only an AB exam. They were allowed to use a scientific calculator, not a graphing calculator, so they must have knew how to do the antiderivative by hand. Okay? Now, I think if this was on this year's exam, I think you probably would have seen the answer like this. I think you would have seen that. I don't think they would have even went to the decimal because you're on the non-calculator part. Okay? All right, let's finish the rest of this. I think we left off here. 31, 31, the derivative of this. This is a good practice right here. How do you take the derivative of v to the u? Itself, ready? Itself, so 3 natural log of x squared times the derivative of the exponent. Now the derivative of the exponent gets interesting here because you've got constant multiple rule and you've got the ln. And it's not just a chain because you're doing chain rule already. You're doing the derivative of v to the x times the derivative of the exponent, but the exponent itself is actually got multiple things you have to do chain rule for. So you're going to first of all do 3 ln of x squared. How do you do the derivative of ln? So it's going to be a 3 times what? 1 over what? 1 over x squared times the derivative of the inside of the ln, 2x. So this one got a little bit complicated because there's a lot of chains here. Okay? There were actually 3 links to the chain. You had the e to the x, you had the exponent, and then you had what's the log, and then you had what's inside the log. So there's really a lot of different things here at work. All right, so you simplify this. The x's will cancel. So you end up with 6 over x times e to the 3 ln of x squared. So the only possible answer there is B. Next problem.
What's wrong?
What?
The answer is E.
The answer is E? Oh, duh. Look at this.
Ln.
6 over x, I didn't even simplify. Put the monkey back in the tree. What is that? Put the monkey back in the tree. That's ln of x to the what?
6.
X to the 6th. What happens? E and ln. Cancel. 6 over x times x to the 6th.
Well, that was not
There you go. That's how you get E. Sorry, I didn't simplify. That was actually on our gateway stuff. Right there. We did that on like 4 gateway tests back in the fall, where you have to put the monkey back in the tree, and whenever you see E and ln, they do what to each other? Whenever you see E and ln together, strong chance it's going to cancel. Very strong chance. This right here, I don't know if let's see. Would this be an arc?
No. Actually, I don't know.
See, the only derivative rule I know is 1 over 1 minus what? Square root of what? 1 minus u squared times du dx?
Yeah, that's not right.
Pretty close though.
Yeah, but it's a 4.
What's wrong?
It's a 4.
So how can I make that not a 4? How can I make that a 1? This is pretty tricky, I'm going to go and tell you.
No, I just
This
did
will
it.
be a strong chance you won't get this one.
I did it.
How can you make that a 1? How did you do it?
I just did it by use substitution.
U equals 4 minus x squared? But du is going to equal negative 2x. There is no x in there.
I know, then you factor, divide by 2x.
Can't do that.
Oh, I did it.
You got lucky.
I
That's not
thought
the way
that's
you do
how I
it.
always did it if there was an x.
Can't do that.
Really?
No. Cannot do that, ever. Because when you convert this over with u substitution, everything has to convert it from x's to u's. That does not work.
Okay.
Here's how I actually do it though. Watch this one. Here's the thing. This is a harder problem. This is an art sign problem. And if you look at it, the problem is it's not a 1 there. I did one last week in the morning if you came. It was an art tangent one like this. What you're going to do is you're going to divide by not just a 4, but where is the 4?
1/4.
Where is the 4? It's under the what? Root. So you can't just divide by 4, you got to divide by what? Root 4, right? Now, here's the deal. Here's the deal. You're multiplying really by 1 over root 4. But if you multiply the bottom of this fraction by 1 over root 4, what do you got to multiply the top by? 1 over root 4. This is a use substitution problem. It's just not what you thought. Okay, so what you're going to get is the definite integral from 0 to 3 of what on top? Root 3, sorry. So you get the definite integral from 0 to 3, root 3, of what on top? It's really just 1/2, right? 1 over root 4 is just 1/2, right? Agreed? Now, that's a 4, not a 9, just so you clarify there. All right, watch carefully here. When I distribute this, what does that 4 become now?
4.
No.
No.
What's root 4 divided by root 4?
Oh,
Whole reason we're doing this.
1.
1. Now, minus x squared divided by 4. You still with me? Now, I want to make it look like this. We're almost there. This does involve u substitution. Now, what can I do with the 1/2? You can throw it out front. Like I said, this one's a tricky one.
Is that AB?
It is AB. This is a harder, it's called a trig substitution. I didn't really do a lot of it when we did inverse tangent, inverse cosine, and that chances are you're not going to see it, but if you do see one this hard, at least you've seen it one time, so if you got a shot at it. So you're going to get 1 over, now watch, it's 1 minus, it's really not that bad though, it's x over 2 quantity squared, there, it's in that form now. Now, here's what you do. What I did, if you had x squared over 4, I made it look like u squared. So I said the whole thing has to be squared, so I'm just going to take the square out and make it x over 2. That's really x squared, that's really 2 squared, which is still x squared over 4. But now it's in that form. What are you going to let u be now? You're going to let u be your x over 2 now. Here you go. So you're going to let u be x over 2. What's du? 1/2 dx. See, when you do your u substitution, when you plug these things in, now I'm going to convert these limits over. This is good practice here. I have a hard time thinking, a lot of you have a hard time getting to here. I understand that. But this part's really good practice because you do need to know how to do this part. If you got to this point, if you were able to get here, you should be able to get this. No excuse, everybody. Okay? But figuring that out would be pretty tricky for a lot of you. All right? I totally understand that. So good luck. Hopefully me exposing you to one of these. Hopefully you don't see one and it's a lot easier. But what we're going to do here is we're going to convert. This is what we've been practicing. This is what you did homework on last night. What do you do with the limits first? Convert those over. Where do you convert them over at? All right? So what's this going to be? 0, right? And then that'll be root 3 over what? 2. Definitely see how this is going to be an arc sine problem. Or arc something. All right? And then right here, we're going to let our u, so we're going to go 1 over square root of 1 minus u squared. There's going to be our arc sine. Now, I need to get rid of the dx. That's gone, that's gone, that's gone, that's taken care of. I need to get rid of the dx. I can't get rid of dx. I got d equals 1/2 dx, so how am I going to get rid of dx?
Well, you would not put the, would not have put the 1/2 up front, it's already at 1/2 dx there.
Well, I multiply by 2 du, and what's going to happen to 1/2? It's going to cancel. There it is. It's gone. Or you could think about it like you did and just replace it all. So now we've got it. This is canceled. What's the antiderivative of this now? Arc sine. Evaluated, arc sine of u, evaluated from 0 to 3 to root 3 over 2. Now, since we converted our limits over, do we need to put our u back in? No, we do not. All right, what's arc sine of root 3 over 2 minus arc sine of 0? Where does sine on the unit circle equal root 3 over 2? First quadrant. You only have to worry about first quadrant here. Pi over what? 6 minus what? Where's arc sine of 0? Where does sine equal 0 on the unit circle?
0.
Pi over 6 minus 0, what's the answer?
Pi over 6.
Pi over 3.
Yeah,
Pi over 3.
Oh, this is pi over 3. Who told me pi over 6?
You did.
There's somebody up here saying pi over 6. That's what it was. Pi over 3, sorry. Arc sine of root 3 over 2 is pi over 3. Arc sine of 1/2 is pi over 6. Somebody said pi over 6 up here. All right, next problem, 33.
That was hard.
Yeah, some of you got lucky and guessed it right or stumbled into the right answer and you didn't know you did the right word. That's okay, you won't know. All right, dy dx is equal to 2y squared, but the way you guys did it is not correct. You just got lucky. Don't do it that way. I'll show you why too if you want me to, if you'll show me your work, Kyle. All right, dy dx is equal to 2y squared when y equals -1 and x equals 1. So if y equals -1 when x equals 1, then when x equals 2, all right, here we go. This is a problem you definitely need to know how to do. This is a start plus displacement problem, believe it or not. All right, here's the deal. They're giving you, listen carefully because I've had a lot of questions on this. They're giving you an initial condition problem. Okay? Now, there's two routes. There's actually two ways you can do this. I'm going to do it both ways. You pick which way you like better. I'm going to tell you one way is a little bit faster than the other. But some of you will have kind of struggled with that. There is the start plus displacement way of doing this. Okay? And then there is the just solve the differential equation, find your plus c, then go back and plug in. Okay? Now, I'm going to start with the start plus displacement because if you do it, and I want to figure out this.
Which way is the faster way?
I'm going to do the fastest way first, but some of you might not like it as much. If you understand start plus displacement, you'll like it. If I want to find a function at a value, and I have the derivative, and this is the part I need to explain. I have a couple people that have been asking about this, so let's make sure we get this right. It's always start plus displacement. But I've been trying to tell you that your start is just all relative to where you started at. Okay, it's relative to like your birthday. Nobody's birthday all starts on the same day and the same time. Okay, in this room, nobody has the same birthday. Okay, we all have different birthdays. We're all born at different times in history. Okay, even if you have the same day, you still weren't born at the same time. All right, so our start is completely different. All right, maybe you can find two people, another person in the whole world that was born at the exact same time as you, but chances are there's nobody else. All right, start. So what's the start value? It's whatever you want it to be. Well, I'm starting. What's the start value? I know that y of 1 equals -1. Agreed? So what's the actual value you're starting at? You're starting at -1. But at what x value did that start at? Now here's the deal. If I'm starting at -1 and I want to figure out where I'm at, and that's when x is 1. So pretend like that's time. Think of it as time, and it might make a little more sense. That's time equals 1. I want to know when I'm going to be at time equals 2. So if I'm at -1 at 1 second, my question is, where are you going to be at 2 seconds? Well, if I know where I start at 1 second, all I've got to figure out is where I've been displaced in that next second and figure out where I'm going to be at 2 seconds. So if I started at -1, all I got to add on is the displacement from what? This is key here.
1 to 2.
There you go. That's it. From 1 to 2 of your function, 2y squared dy. Now it's just really a one-step problem. You integrate it, FTC it, done. So it'll be -1 plus, what's the integral of 2y squared? 2y cubed over 3, evaluated from what? 1 to 2, and that's going to figure out the displacement. It's going to figure out how far you're displaced from 1 second to 2 seconds. So if I plug in 2, you're going to get 2 cubed.
16 thirds.
Yep, 16, so that's going to be plus 16 thirds minus what? 2 thirds? What's 16 thirds minus 2 thirds? 14 thirds. You got -1 plus 14 thirds. That's going to be -3 plus 14 thirds, which is what?
11 thirds.
Negative.
Why don't I see 11 thirds?
The answer's
What did I do wrong, guys? I did something wrong. Starts at -1, 1 to 2, 2y squared. Add 1 to the exponent. Did our antiderivative right. Plug 2 in. 2 cubed is what? 8 times 2 is 16. 16 thirds minus. Plug in 1. 1 to thirds 1. 2 thirds. Is that right? 16 thirds minus 2 thirds is 14 thirds. -1 plus 14 thirds. It's really -3 thirds plus 14 thirds. Which is 11 thirds. Why did I see the answer? Let me do the other way. What am I doing wrong?
I think we have this wrong.
Let me stop the video. I don't want to sit here and talk about